Welcome everyone to our presentation on nuclear energy fundamentals and safety components. My name is Jill Baker and I'm the regulatory lead for the Peace River Nuclear Power Project. This presentation is meant to provide some basic information on nuclear energy and some of the safety components related to nuclear power plant facilities. On the right-hand side of this slide, you'll see a couple questions related to this topic, which we are offering up as potential conversation starters at the end of the presentation. Here you'll see the outline of the topics I'll quickly go over this evening. Under nuclear fundamentals, I'll touch on key facts about nuclear energy, the science of nuclear energy, and how our nuclear power plant works. There's many aspects of safety that could be discussed. However, for tonight, I'll only go over the following: safety components of the project site selection process, radiation safety, nuclear emergency preparedness and response planning, nuclear power plant security, and nuclear waste management. To start, a few key facts about nuclear energy. First, nuclear energy is reliable and consistent. Nuclear power is considered to be baseload, which is essential for a stable, reliable electricity grid. Nuclear power plants are up and running for most of the year, and therefore they can provide a constant and reliable source of electricity. Second is related to greenhouse gas emissions. Nuclear power is recognized as a low-carbon source of energy, as it produces virtually zero greenhouse gas emissions during operations, and therefore it can play a key role in the transition to a clean energy future. Third, nuclear energy power plants have robust safety systems. The nuclear industry is one of the most regulated and monitored sectors in the world, and facilities are inspected regularly to ensure that they meet or exceed strict safety standards that are established by the Canadian Nuclear Safety Commission, as well as adhered to global safety recommendations set out by the International Atomic Energy Agency. Next, nuclear energy has high energy density. This means that a small amount of nuclear fuel can generate a tremendous amount of energy. For example, a single uranium pellet is about the size of a AA battery, and it can produce the same energy as 907 kilograms of coal, 564 liters of oil, or 480 cubic meters of natural gas. And finally, a point about energy security. Nuclear power will help diversify Alberta's energy supply and therefore offer a path to a long-term energy security and independence. Nuclear energy is the energy that is released from the nucleus of atoms, primarily through a process known as nuclear fission. Fission is a reaction that occurs when atoms of uranium are split into two or more small nuclei. In this diagram, an atom of uranium is split by the impact of a neutron. The neutrons that are released then go on to split other uranium atoms, causing a chain reaction. During this process, a significant amount of energy is released in the form of heat. This heat is converted into electricity by creating steam in a nuclear power plant, as I'll explain on the next slide. This diagram shows the basic components of a nuclear power plant, which includes the reactor core, which is in the center of the diagram, the steam generator above the reactor core, the steam turbine, which has a condenser located on the right-hand side of the diagram, and off to the left is the control room and a box representing the spent fuel pools where used fuel bundles are stored. At its most basic explanation, nuclear reactors produce electricity by splitting atoms which release heat. This heat converts water into steam, which in turn turns a turbine that spins a magnet, causing electricity to flow to the grid. A few things about core basics. Uranium, as mentioned, is the source of energy. It's put into the reactors in the form of fuel bundles. There's several hundred fuel bundles in a reactor at one time. The fission reaction takes place inside the reactor core, creating heat, which is then transferred to the heat transport system. The high-pressure steam that is created is transferred to the steam turbine and generator to create electricity for the grid. The heat is carried by a reactor coolant system to the steam generators, where it heats water to produce steam. The heavy water leaving the steam generators is then returned to the fuel channels to repeat the process. After steam passes through the turbine, it is also cooled and returned to water, which is then returned to the steam generator to be heated again, and the cycle repeats. The cooling water used in this process is kept separate from the steam cycle and does not come into contact with the reactor core. These streams of water are kept separate from each other. Now we'll move on to a bit about safety. Energy Alberta is deeply committed to safeguarding the air, land, water, and communities near our proposed project. Safety is not just a priority, it is at the core of our values. There are a few key points to make it at the start when talking about safety. First, nuclear energy is one of the most regulated and closely monitored energy sources in the world. Safety is paramount. Second, there are decades of safe nuclear energy production in Canada, with the Canadian Nuclear Safety Commission overseeing every stage of plant development and operation. The Commission is considered one of the most respected nuclear energy regulators in the world. And related to this, oversight of the sector is also provided from the International Atomic Energy Agency, which underscores our commitment to meeting the world's highest nuclear safety standards. We'll start by talking a little bit about the safety components that are involved in the current site selection process. The CNSC set out very specific site selection and evaluation criteria, which Energy Alberta must adhere to. These requirements are also backed up with the international requirements of the International Atomic Energy Agency. Site selection for nuclear facilities is closely tied to safety and security. Energy Alberta looked at 66 criteria in total in the site selection process, which you will learn about more in another detailed presentation. These criteria fall into three categories: environmental, social and cultural, and technical. The safety components of site selection are included under the technical category. The hazards that were assessed included human-induced hazards, which include looking at existing facilities such as pipelines and oil and gas wells, and environmental or external hazards, which includes events such as seismic activity, floods, and forest fires. To provide an example, let's look at seismic activity. We want to avoid building in areas of moderate to high seismic activity, as well as far away from injection plants. We looked at natural seismic hazards based on past data, and also looked at the seismic risk from injection plants or gas processing plants. We created maps that lay out the potential for both of these hazards and overlaid that on the maps with the project locations to determine if the project sites are in areas considered to be moderate to high risk, and they are not. Next, we'll talk about safety measures in Canadian nuclear facilities. Nuclear power plants are engineered for protection at every level. The safety of nearby community and plant workers is central to every part of nuclear power plant design and operations. Multiple independent control systems will ensure plant safety during all operating conditions. Safety measures in Canadian nuclear facilities can be categorized into the following four areas. First, containment structures. There are thick, reinforced concrete walls that prevent radiation from escaping in the unlikely event of an incident. Next, there's radiation shielding. This includes materials like water, lead, and concrete that all protect both workers and the public. Next is continuous monitoring. Radiation is measured around the clock and outside the facility to ensure levels stay far below health risk thresholds. And finally, there's air quality protections. This includes advanced filters that remove over 99% of radiation from the air, ensuring that the public and the local ecosystems are protected. Radiation safety is at top of mind for people. For more than 60 years, Canada has been a global leader in nuclear energy research, technology, and development, operating under some of the world's most rigorous safety regulations. To begin, it's important to note that there's different types of radiation, and it is ionizing radiation that is associated with nuclear power plants. People are exposed to non-ionizing radiation and naturally occurring radiation in our everyday lives. For safety around ionizing radiation, the Canadian Nuclear Safety Commission sets out rigorous radiation standards, which includes limits on radiation exposure for workers and the public. Nuclear power facilities must adhere to these radiation protection regulations, which are set out under the Nuclear Safety Control Act, as well as recommendations from international organizations that provide global safety standards for radiation exposure. Nuclear safety goes far beyond reactor design. It includes robust physical security and a culture of emergency preparedness. First, let's talk about site security. The security requirements are designed to safeguard nuclear facilities against infiltration or attack and ensure that nuclear material stays safe and secure. Some of the main security requirements include the following: annual threat and risk assessments, on-site armed response forces that are available 24 hours a day, 7 days a week at high security sites, enhanced security screenings of employees and contractors involving background, police, and security checks, as well as enhanced access controls for nuclear facilities. Next, a bit about cybersecurity. Cybersecurity is the practice of protecting systems, networks, and programs from digital attacks. Every critical infrastructure, including that of a power plant, relies on the effective cybersecurity measures to protect against these attacks. The Canadian Nuclear Safety Commission requires nuclear power plant licensees to have a cybersecurity program that meets the requirements of the Canadian Standards Association. The Commission conducts inspections to confirm compliance as well as program adequacy. And finally, a word about emergency preparedness. The Canadian Nuclear Safety Commission sets out requirements for emergency preparedness and response plans for nuclear power plants in its regulatory documents. Every nuclear power plant must maintain and regularly test a full emergency response system, including trained teams, equipment, and detailed response plans that are overseen by the Commission experts. As has been mentioned, nuclear safety in Canada is regulated by the Commission, which sets out detailed safety requirements for all of Canada's licensed nuclear facilities. The Commission has strict requirements and guidance related to safety, with many regulatory documents that are specific to what's known as safety and control areas. There are several different aspects involved in safety and guidance, and is provided to facility operators for several areas such as the following: safety culture, personnel training, construction, plant operations and maintenance, safety assessments, nuclear fuel safety, radiation protection, waste management, security, as well as packaging and transport. Nuclear emergency preparedness and response planning is critically important. The Canadian Nuclear Safety Commission sets out the emergency preparedness requirements and guidance related to the development of emergency measures. Their guidance is based on international guidance from the International Atomic Energy Agency and is consistent with modern practices. The requirements that a nuclear operator must implement in their emergency preparedness program has four main components. The first is planning basis. This includes an analysis of all the risks and hazards that the emergency planning program will address. Second is an emergency response plan and procedures. This includes a comprehensive description of how a response will be executed. The next stage is preparedness. These are the processes to ensure that people, equipment, and infrastructure will be ready to execute a response according to the emergency response plans and procedures. And finally, the last component is the program management. This is the management system aspects that assure the effectiveness of the emergency planning program itself. Finally, we'll end on a note about nuclear waste management. The Canadian Nuclear Safety Commission regulates all radioactive waste in Canada. When it comes to the transportation of radioactive waste, the Commission shares this regulatory responsibility with Transport Canada. Together, they ensure that nuclear waste is transported and stored in a controlled, consistent, and safe manner. All of Canada's used nuclear fuel is safely managed at licensed storage facilities. There are strict security measures in place to ensure that there's no threat to public health from stored used fuel bundles at these facilities. The short to medium-term storage and management of used nuclear fuel is the responsibility of the facility operator, and it is closely monitored by the Commission in direct cooperation with the International Atomic Energy Agency. However, the long-term waste management is the responsibility of the Nuclear Waste Management Organization, also referred to as the NWMO. The NWMO is currently implementing Canada's plan for the safe, long-term management of used nuclear fuel through the development of a Deep Geological Repository, also known as a DGR. As noted, facility operators in Canada are responsible for the safe and secure storage of all waste on site. Energy Alberta will be responsible for the safe and secure storage and management of all levels of waste over the short to medium term on its licensed site. There's different levels of waste, but for the purposes of today's presentation, we'll briefly touch on the management of used fuel bundles. On-site used fuel management includes spent fuel pools and dry storage facilities. A photo of a spent fuel pool is on the left and a dry storage facility is on the right. Once fuel bundles are used up in the reactor, they are stored first in the spent use pools for 7 to 10 years. These pools are about the size of an Olympic-sized swimming pool. After a fuel bundle has been in the pool for the required time, it's transferred to the dry storage area, the casks which are seen on the right. The dry storage area will be located on the project site, and bundles will remain here until a permanent storage facility location is identified for them to be transferred to. As I mentioned, used nuclear fuel is managed on site until it is removed for long-term storage at another location. The radioactivity of the fuel bundles decrease with time for the first 7 to 10 years in the pool, and then further on in a dry storage containment facility which is on site until a long-term storage site is secured. There are strict Canadian and international standards for the management of spent fuel. When safety protocols are followed and measurements put in place, nuclear fuel does not pose a danger to people or the environment. And finally, people are often interested in knowing how much nuclear waste could be generated from the Peace River nuclear power facility. To visualize this, if you stacked all of the fuel bundles like firewood, all of the fuel could fit into about 5.5 hockey rinks from the ice surface to the top of the boards. And that concludes the presentation. Thank you for your time. Next, we'd like to hear from you and what matters to you. What aspects of nuclear energy would you like to learn more about? And what aspects of safety are most important to you and the community?